All right, everybody, here we are. We're starting to figure out nomenclature, and we are starting with ionic compounds. So ultimately, we will have to double check if a compound is ionic or not, but because we've only learned about ionic compounds, we know that all of these are going to be ionic. The other way you can tell is that they all start with metals, or the Roman numerals in a name are a dead giveaway that a compound is ionic. If a compound is ionic, if we want to write the formula from the name, we should set up a drop swap. So if we're given cesium oxide, I know cesium is Cs. I know oxide comes from oxygen. And according to the group that each of these elements are in on the periodic table, cesium is a +1 charge, and oxygen is a 2- charge. So then I do my drop swap, and the formula I should get for cesium oxide should be Cs2O. Now let's try silver carbide. Again, I know this is ionic because of that metal out front. Silver is Ag. Even though it's a transition metal, it only ever has a charge of +1. So I know silver is a +1. Carbide comes from carbon. Now on your periodic table, carbon could be a 4+ or it could be a 4-, but remember, an ionic compound is made up of an ionic bond, which is the attraction between opposite charges. So carbon has to be a negative charge here. So then I'm going to drop swap, and when I do that, my formula should be Ag4C. So now let's talk about these transition metals. The Roman numeral tells us the charge, but as always with metals, it's going to be positive. So tungsten, because of this Roman numeral, is a 6+. Phosphide comes from phosphorus, and on our periodic table, we know that that is a 3-. When I drop swap, I should get W3P6. But remember, with our ionic compounds, we want to write the smallest representative unit, which means, like a fraction, if I can reduce or simplify, I will. And so this should give me WP2 after I divide both subscripts by their largest or greatest common denominator. Now let's talk about titanium. This is Ti. It is a transition metal, but the charge is given to us. It is a 4, and because it's a metal, it's a plus. Oxide comes from oxygen, and that's a 2-. Now I set up my drop swap, and that is going to give me Ti2O4. But again, with ionic compounds, we simplify. This should be TiO2. Commonly, this is referred to as titanium dioxide, although it shouldn't be according to our rules. This is a component in many cosmetics. It's sunscreen. It's typically a white tint. So now, what if we want to go the other way? We want to name all of these from the formula. Same idea, we know all of these are ionic if you wanted to double check this metal out front. What we need to pay attention to is if we have a transition metal, we need a Roman numeral. Now, we have Zn, we name that zinc. Zinc is a transition metal, but it's another exception. It is always a 2+, and so I don't need a Roman numeral. Then I name my anion with that IDE ending. This is zinc oxide. Let's try the next one, Vs2. We name our metal, as always. V is for vanadium. It is a transition metal. It has multiple possible charges, and so I know I need a Roman numeral. So I start with my reverse drop swap check. This 2 will go across and up to become a 2+ on my vanadium because metals are positive. And then the 1 that isn't written but is assumed goes up and across and gives me a sulfur 1-. Have to have opposite charges. Now I double check. Is sulfur a 1-? No, it's a 2-, so my reverse drop swap has failed. And now I have to do a little bit of algebra. I start with my anion. In my formula, I am given 2 sulfurs, and each of those sulfurs has a 2- charge, which means my total negative charge for this compound is 4-. Why do I care about the total negative charge? Because every ionic compound has a total charge of 0, which means if my total negative charge is 4 plus, my total negative charge is 4 minus, my total positive charge has to be 4 plus to get me to that 0. So now I can start tackling my vanadium. According to my compound, I have 1 vanadium, but I don't know its charge, so I make that X. Now I solve for X, I divide both sides by 1. 4 positive divided by 1 is 4 positive. So my Roman numeral is the Roman numeral 4 in my name. Then my S, I still give that IDE ending. So this is vanadium 4 sulfide. Let's try another one. CrN2. Cr, we name it as it is, chromium. It is a transition metal with multiple possible charges, and so I do need a Roman numeral for this. I start with reverse drop swap. That gives me Cr2 plus and N minus. Unfortunately, drop swap fails again, and so I need to do my little algebra problem. I start with my anion. I have 2 nitrogens, and according to my periodic table, each one has a charge of 3 minus. So my total negative charge is 6 minus. Now I can tackle my chromium. I know my total positive charge has to be 6 plus to get me to that neutral. I have 1 chromium in my compound, and its charge is unknown. So then I solve for X, divide both sides by 1, and my chromium has a charge of 6, which is Vi in Roman numerals. Then my N gets that IDE ending to become nitride. So this is chromium 6 nitride. Let's do the last one. We name the metal as is, lithium. Lithium only has 1 possible charge, so it doesn't need a Roman numeral. And now I can just name my anion. Gets that IDE ending to become lithium bromide.